Good afternoon, everybody. So it's been a tough day and a half. Good news is only another half a day to go. So I'm going to be talking about balancing forces in software design. So software design is an activity that is essentially to come up with a solution to a bunch of requirements, right? The problem is that we often concentrate on the solution and not enough on the problem. So the problem can be viewed as a set of forces, or the requirements can be viewed as a set of forces. And these forces often conflict with each other or interact in some other way. And the idea is to resolve these forces, and in resolving these forces, we can actually come up with an optimal design. So insufficient requirement analysis leads to suboptimal design. When we think of software design, we think of classes, we think of microservices, we think of even processes, and so on. We kind of pay a cursory nod to the requirements, but most of the time, we are actually engrossed in what the solution should be, and we don't try to understand exactly what the problem is. And it's complicated. The problem comes in many shapes and forms, and to kind of think of it holistically is very difficult, so we often don't do it. But it's the context, the problem can be defined as a context, and it's the context that actually shapes the solution, right? So when we talk about all these different solutions, we are often debating forever on what's the right, whether it should be microservices, whether it should be the monolith, whether it should be Kubernetes or Docker or serverless or so on. But we often don't get to a good solution because we don't understand the problem well enough. We don't understand the problem holistically. We don't understand the different trade-offs that actually are in there within the problem. And so we don't know, first of all, what the solution should be, if that's a good fit. We might have some idea because the problem looks similar to another problem we saw or someone said it. But even if we pick the right kind of set of solutions, we still don't know how to adapt it to our context. So often, we come up with a solution that is not the best fit to our problem, right? So the problem defined at the right level, and that's where the key is. If we define the problem at the right level, we can see these forces emerge. We can see the forces that we need to balance, and we can see how they conflict with each other. So here is the skill, because if we define the problem at too detailed a level, and that's what we usually do, because when we see the whole thing, we normally either see a vision, which is very abstract, or we see a backlog, which is too detailed. And we don't actually see the wood for the trees. We are lost in the detail, and we don't understand how these things interact with each other. We will normally pick a subset and try to devise a solution according to that subset of requirements, because we can't see the whole picture. Or we have some sort of a vision statement or some sort of a release roadmap or something, and but that's too abstract. So we can't really see how those different aspects of the problem actually interact with each other. So that's what this talk is about. This talk is about us trying to understand the problem from a holistic point of view and see how all these forces interact with each other so that we can come up with a design that is optimal, right? So some of you might be thinking, well, that's common sense, right? It's stating the obvious. It is. But I'm afraid to say common sense isn't that common, so it's worth saying. But you may also be thinking, well, that's interesting, but how do I apply it? And I'll try to address some of that in here, but this is, again, related to a skill. And the idea is for you to come out of this talk with an inspiration to go and think more and research more and try to understand. When you go back to your projects or your products, you are trying to understand it more from a holistic point of view. But I'm not the only one who's saying it, right? So this is not new. In fact, in building evolutionary architectures, they define the concern of, or the activity of building architectures or design. I consider design as architectures and at all levels to be design and problem analysis to be design. They consider the activity of architecture as a solution, or good architecture is a solution that balances all concerns optimally. So they try to define good design from that point of view. You innately start thinking about trade-offs, and good design is the thing that brings all these trade-offs into balance, right? And it's not just about software. Christopher Alexander, who is the inspiration for this talk and his books, he describes design is often about achieving a balance between conflicting forces. So these guys, every time, or these people, every time they have tried to describe what design is, they automatically start thinking of trade-offs. And trade-offs then is all about forces that are in interplay with each other and how we balance them, right? But the problem is that we don't do that enough in a deliberate manner. So, in short, design is about taking these forces, and in design theory they call it the context. Context is much bigger than what we normally think the context is. The context is the whole problem domain and how it's interacting with each other, and how it's interacting with the solution. So the design, or good design, is about bringing the context, which is the problem, and the solution, which is the form, into harmony with each other. And that's a good fit. That's a good design. So let's give you an example, because it's been a bit abstract so far. So this example I've taken from Christopher Alexander, actually. We will get to software in a little while, but let's simplify it first to drive home the point. So in this case, he uses the example of an electric kettle, right? So that's the solution, right? So we need to heat water to make tea. And there is a context. And the context, part of the context is that it needs to sit on a kitchen top, and it needs to plug into a standard electric socket. So there is an interesting point here, actually, because if you draw the context elsewhere, if you draw that boundary between what's your problem and what's your solution, you can end up with very, very different designs, right? And it's important that when we are thinking about our designs, that we're also thinking about where are we drawing this context solution or context form boundary. In this case, if they said, okay, well, it doesn't need to fit into a standard electrical socket and doesn't need to stand on a kitchen top, I could also say, well, it could be just a tap that has a built-in boiler that boils the water for me to make tea, right? So the solution would be completely different. But in this example, let's take the form and context boundary to be that it needs to fit into a standard electrical socket. So what are the forces at play here? It needs to heat water. They look like requirements, don't they? Needs to be powered by an electrical socket. Stands on the kitchen worktop, not too small, because maybe I need to boil water for 2, 3 people or for 1 person. Not too difficult to pick up, because it can be hazardous. It's boiling water. Not easy to let go by mistake, obviously. Easy to store in a kitchen, so I may need to store it in a cupboard as well. Pour cleanly. Not let water cool too quickly. Materials must not cost too much. Economical to manufacture. Must not corrode. Must not be too difficult to keep free of scale. Easy to clean. Economical in heating smaller quantities. And must not boil dry, right? So there's a bunch of these forces or requirements. They are defined at the right level because we can already start seeing conflicts, right? So let's take just one of the forces and see how it interacts with the others. So powered by electrical socket, interacts with stand-on kitchen top, because if we put the socket underneath the kettle, it won't stand. So already our solution space is constrained. Not too difficult to pick up. Already tells us what kind of form it needs to have. It needs to have a handle at the very least, but how big it needs to be, right? But that actually may have an impact on how it's shaped, where the actual plug is, whether I need to be able to lift it without by detaching it from a base, or if I lift it and it's still connected, will it be easy to pick up? Not easy to let go by mistake. Again, conflicts with the other. Easy to store in the kitchen, so we know that it needs to be a particular size. It can't be too big, but then it may actually interact with the not too small as well in that case. Materials must not cost too much. Again, certain materials don't play well with electricity, right? Economical to manufacture, again, that shows that there are certain materials that may not play well with electricity, but even then, I need to pick the ones that actually are economical. Must not corrode, because it's electricity, it could cause damage. Must not boil dry, right? It's electrical, so maybe there is an impact there because I need to find some way of switching that off when it reaches a certain temperature. Suddenly, you start seeing these interplay between these forces, these requirements. And usually, we don't think like that. We are too engrossed in a particular story or a particular feature to look at the solution holistically. Do we think of the solution holistically every time we are changing the solution? Most likely not. We very rarely have a full view and what this particular feature, what kind of impact this particular feature has on everything else. And I'm not talking about just other functional features. I'm talking about all the forces that are at play here. All the cross-functional, all the organizational, everything that's at play here, right? So I'm asking a lot. Is this big design up front, though? We don't like big design up front. In a way, yes, because the kettle, in this case, actually we are trying to come up with a form that is static. Once we've designed it, it's produced, we can't change it. The only thing the statement we are making is that if the context, if the balance of these forces changes, if suddenly I no longer want it to be powered by electricity, my form is obsolete. My solution is obsolete. That's what we are saying in this case, right? But it still applies to our context, where the context keeps changing and our form needs to, or our solution needs to keep adapting to that context. And it does apply. Just because our context keeps changing does not mean that we don't need to think about it. We need to think about the context that we have now, the context that we can predict, and everything in between, and where the context may change in an unpredictable way, and what will happen then as well, right? It's not big upfront design. It's actually big upfront problem analysis, BUPA, right? It's understanding the problem, and it's understanding where the problem is, where all these forces interact with each other. It's about understanding the whole and seeing how that whole actually applies to my solution. is this big upfront design, right? Every tree that we see, or most of them, have a trunk, they have branches, they have leaves, they have roots, and so on. So, but no single tree is the same, no two trees are the same. They're all unique as well, right? So what part of the design is big front and what is incremental or progressive, right? And also, if you look at the progression of the design from a seed to a tree, in each stage or in a continuum, is actually a complete design. It's not a half-baked design. It's not like um, a, a, a seed in itself. It's not like a half a seed or it's not half a tree. It's a seed. It's there. It has a bunch of forces that are at play and it's resolving those. And those forces change, but it's built into that progression is actually built into the design, right? So you can call it evolutionary, you can call it progressive, you can call it incremental, but actually the whole problem has been thought of. The problem has been thought of all the way to where it will end up, and the things that will remain the same and the things that will change. And where the context may change and the other things that will have to remain as they are. So we're often not even aware of the full context, as I said. So, but we still need to come up with this progression. We need to be able to predict, and we need to see what things will change, what things we're still not aware of, and we still need to analyze the problem as a whole. And modularity is another key concept in analyzing the problem. It's not just about the solution, right? We talk about coupling and cohesion, and we only think solution. We think how our different modules are behaving, that they need to be cohesive and decoupled from others, or microservices, and so on. But actually, the root cause of those dependencies is within the problem, right? So we talk about this inherent and accidental complexity within our design. The inherent complexity is the complexity in your problem domain, not in your solution. The accidental one is the stuff that you add on top, the complexity you add on top other than the problem. So modularity, when you think of modularity, if you're just thinking about the solution, you're in a world of pain. You need to think about the problem, and you need to think how modularity applies within that problem, how it applies as a bunch of conflicting forces, and where those forces are strong with each other, and where they are weak. And that's where you will see modularity, right? And that's not necessarily the same as solution modularity, although it needs to drive the solution modularity, but we generally don't do it as well. So we come up with arbitrary divisions because we don't really want to think about the problem as a whole, because it's too complicated. So, who knows what lexical sets are in English language? No? Nobody? All right, one. So a lexical set is basically a grouping of things, right? So animal is a lexical set, and it has members of cat, dog, blah, 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 right? So normally what we do is, rather than looking at the problem in a much more meaningful way, an easy way to think of it is, you know what, this is cart, and this is checkout, and this is that. These are lexical sets. They of course say something about the problem, but they're actually about linguistics. They're not about your problem. So when you start thinking about those lexical sets, and you start dividing your solution in those sets, you don't really know the forces that are at play here, and you don't really know whether that lexical set, actually there's a bunch of forces in there that are interacting really strongly with another one, because it's an arbitrary division. You might get lucky. I'm not saying it's completely invalid. You might get lucky, but it's not the only view. It's more often not the only view. So that's what I mean. Look for the dependencies in your problem. So come up into your problem and do some problem analysis and try to define it at a point where the dependencies start becoming clear, right? So that's when you start seeing where the clusters are. That's when when you start defining the problem at a level. It's not too abstract that you can't see, it's useless, you can't see anything, and it's not too detailed that you are lost in the detail. You have to experiment and you have to see where you define the problem to start understanding how it interacts with each other. And that's when you start understanding the links between the different forces. And that's when you can actually start clustering, right? So then you can see, okay, I have a kind of a cluster here and a kind of cluster there, and that's when you start understanding these are my modules or my clusters in my problem domain. So let me explain this a bit further, and this again is an example from Christopher Alexander. So he describes looking at these forces and how they interact with each other. He explains them with this example of a system of lights. So take each one of these dots as a light, right? And they have an on and off state. And if they're off, if it's already on, there's a 50% chance of it going off in the next second. But if it's off already, and if it's not connected to anything else, it won't come back on unless an external thing changes it. But if a light is on and is connected to a light that's off, that light that's off has a 50% chance of coming on in the next second, right? So this state where nothing is connected, if you turn one particular light on from an external force, all the other lights are off. The chances are 50% that that light will go off in the next second and no other light will come on, right? So you go back into equilibrium, right? But let's now take the view that all the lights were connected to each other. So they were all interconnected. If you turn one light on, there's a huge chance that a few other lights will come on in the next second. And when those are on, there's a huge chance that more lights will come on in the next second. A few may go off, but more will keep coming on, to the point where all the lights will be on, and they'll be coming off, but the system is now pulling towards all the lights staying on, right? So on one hand, you have a completely stable system. So let's say that all the lights going off is our definition of stability. On one hand, you have a completely stable system. On the other end, you have a completely unstable system, right? So if you were to wait for all the lights to go off again, you're probably waiting on average around over 1 million seconds. But then if you cluster them, and then you start looking at the connections between those clusters, and you kind of break those dependencies in some way, anti-corruption layer or whatever solution you want to take, the chances of going back to a stable condition, even with those connections, just taking off 1 or 2 connections in the right place makes your system a lot more stable. But again, we are still looking at the problem. We are not looking at the solution, right? We are still trying to understand where are the key areas in a problem and how I frame the problem so that the solution is obvious, right? So that's what I meant by the problem frames the context frames your solution. So as I said, reducing conflicts allows you to naturally stabilize your solution, right? So you want your solution to be in a particular way. You keep thinking, why is it that every time I try to take my design to a particular direction, things keep changing and nothing actually works? Well, that's the reason. You need to understand how the different forces in your problem domain are actually interacting. So can we apply this to software design, right? We've given the example of a real-world object, right? But does this apply to software design? So first of all, I was kind of trying to think, well, let's come up with a whole example. But the problem with that is that the example will be huge. And it's a talk in its own right, or maybe a couple of talks. So what I'm going to do is simplify. So we're going to talk about just functional testing, right? So our design decisions in functional testing may be like, kind of how should my testing landscape, how should it be laid out, right? Should it be like a right way pyramid or upside down, or what kind of utility test and what kind of production tests I might have, right? So when we are trying to decide, normally we all go and say, you know what, it's kind of perceived wisdom. Oh well, up to about a few years ago, it was kind of perceived wisdom. You know, we need that kind of the right way up triangle. We need lots of unit tests, we need some integration tests, UI, we need some performance tests on the side, and so on, right? But we always look at it from a solutions point of view. It's as if testing is the problem. Testing is not the problem, or functional testing in this case, as we're trying to constrain the thing. It's not the problem, it's a solution, right? So what's the problem? And how does it interact with each other so that it gives us, it illuminates how we should be testing in a particular context? Oops, sorry. So I'm taking a payment, kind of a shopping cart thing, to just kind of illustrate an idea and a few features. So imagine it's a website of some sort where you search for some products or see products, add them to a basket, and buy them, right? So I'm just taking a few things because just to illustrate how these different forces need to be laid out for you to start seeing the interconnections between them. So in this particular context, well, there may be many payment methods. So I need to understand, how do I test that, right? Because if there's lots and lots of them, do I need to kind of isolate that part and test that? Do I need to test it through the UI? Do I need to just test the service? Where's the complexity and so on? But there is that side I know I need to deal with in a very special way. Product search needs to be accurate, right? Do I always test that through the UI? Because I need to make sure that when people are entering all sorts of words in there, they get to the right product, right? So what kind of, does it need to be exploratory? What does accurate mean? Can I just isolate the search and then have certain criteria and kind of fuzzy matching and make sure that it works and automate that? Standard search display, that's quite standard, right? I know that it needs to be, it's where people start buying things from, but I'm not going to change it much. Do I then automate that UI test? Or do I make sure that it's, like every exploratory test, people are looking at that it doesn't go wrong in any way? But it's quite standard, it doesn't change that much. Verification of good fit. So this is kind of a high-level thing that I need to make sure that the whole thing, the functionally is working, right? So does that mean that I need to test everything right at the top? But that may, well, we'll see, it may clash with other things. But then if I test everything at the bottom, how does it connect with each other? Do I still get that, right? Immediate feedback of bad fit, right? So I need to be very quickly told that if something goes wrong, if something is functionally not accurate, I need that immediate feedback. So at what level am I testing for that feedback? Again, they are conflicting already with each other. See bad fit in full context. So if something bad happens, I need to see what exactly, from a holistic way, what in my product is no longer working, right? Quickly locate bad fit. That's kind of the opposite, to say that, well, if something goes wrong, I want to know where this bad fit is, where this defect or error is. Change must be cost effective, right? So when I'm coming to make the change, there needs to be, if my test landscape is really complicated, I need to change that first and make the change happen. Is that cost effective, or actually me just doing some exploratory testing and making sure that works? Is that cost effective, and what about the long term, and so on? But these are the decisions that you need to make. Verify solution integrity during changes, right? So also, I want to, as part of this, I want to make sure that how the solution is, it needs to be held in the right place. In some places, it needs to evolve in others. Is that is my testing landscape gonna hold the solution in that place? Is it gonna tell me that it has integrity in the places where we have already made a decision that this is how it should be? Minimize false negatives, right? So if something is right, it shouldn't tell me that it's wrong. And also, multiple teams may be working with each other, so that's another impact that may have in how I choose to do the testing, right? Evolve with changing requirements is the opposite of holding the design in place, in the sense that, when my requirements change, is it going to support changing those requirements, right? So I am looking at the problem. This is a very small subset of the problem of functional testing, right? The testing pyramid, or the this test here and that test there and so on, they are the solution. When you start to look at the problem from that perspective, and you define it at a level where you can start seeing things interacting with each other, that's when you start getting real insights into what your solution should be, right? So these are the forces, some of the forces that you need to balance when you are thinking about testing, right? So when you are debating about what kind of test to write, what you should really be talking about is what solution will satisfy my requirements in a holistic manner. Another example, similar kind of thing, an API. I need to build the API. I need to design that API. So, suddenly I'll go GraphQL because that's like the new thing, or REST maybe because, it's an old dog, it works, or something else. Well, But actually, these are all the things that we discuss when we are talking about APIs and many more. Does it need to be generic or specific? Because if it's specific, I need to change it all the time. If it's generic, it's not kind of descriptive, but at least I don't need to change it. The client doesn't need to change all the time, maybe. Federated, does it need to kind of have its own API, lots of small APIs, or one big API? Rooted, is it, do I have something in the front? And then that's kind of routing to a demilitarized zone or some other services, or is it just every service has a direct one? Is it versioned or not versioned? Is it monolithic, or is it microservices? Is it event sourcing? Do I need to use event sourcing for my API? Do I need to have aggregated logging between them? If they are federated, does it need to scale? Is it public or in a demilitarized zone, as I said earlier? Is it asynchronous or synchronous? REST or GraphQL, right? So those are all the different ways that we think when we are looking at API. That's what we're thinking. We're thinking solution and then kind of cursory nod to the problem, right? So forces maybe in here are unclear what data needs to be displayed in product lists, right? So we don't really know yet what kind of data needs to be displayed there, right? So if we have a kind of a very specific API, that's going to change a lot, because the client may need to change a lot. If we have a bit more flexible, again, like REST, GraphQL, maybe, there might be some, might be more relevant, right? Payment must go through PCI compliant infra, for example, right? So this has a massive impact on how that part needs to look like, right? So again, it's not a, we're not thinking about, is it GraphQL, is it this, is it federated or not? What we're thinking about is what problems are we trying to solve and how they interact with each other. Teams are divided over organizational boundaries, so how will we sort that out in our solution? Multiple individual teams developing at the same time, right? So everyone's developing. Are they going to have their own bits of the API? Is it, are they sharing it? How is that going to work? How are they going to deploy that into different environments? These are the things that we start to think about. Certain processes have a formal handover, kind of enforces that PCI side of things as well. Some things can move quite fast. Other things are quite slow, have a formal process. Clients and APIs evolve at different pace. So also we need to think about that, right? Again, then it starts informing our choices about version, not version, these kind of things, specific, generic. Change must be cost effective, right? Again, that's a force that is at play here, and it will impact the others. Recover from transient errors. That will also impact your API and how you design it. Evolve with the changing requirements. Support significant shifts in the context. So this is about, oops, sorry. So suppose significant shift in the context is about understanding that, you know, in certain cases, my solution is unpredictable. I'm not really sure what that will look like. And your design needs to cater for that, right? Responsive operation, in some cases, is necessary. So then if it's asynchronous or synchronous, how would that be? If it needs to auto scale, how would that be? Economic with changing demand that has an impact on responsive, has an impact on auto scaling, has an impact on how you lay out. Secure during change and operation, right? So that also has an impact on what your service looks like, what security means, what that solution would be, and how that again impacts with many other things. Describes the structure and operation, so it needs to be descriptive. So descriptive, so that conflicts with at least generic versus specific, how you're going to kind of deal with that, right? So these are the things that you need to be thinking of when you are looking at API design. Not GraphQL versus REST versus God knows what else is out there now, right? But when you start thinking of those, it will start illuminating your solution. You will start looking at your solution and see whether it's a fit or not, whether it's a general fit, and also how it needs to be adapted for it to be a good fit, right? So, in practice, this is, it's not a thing that we do that often. But in fact, when you look at any kind of good material, you start seeing where it's missing, in the sense that people are talking about it, people are saying that it needs to happen, but because the emphasis is not there, we don't see it as a problem. We just kind of go straight down towards the solution. So ADRs, architecture decision records, right? We talked about them yesterday. I think James was talking about them yesterday, right? In there is this template, the title, the context, the decision, the status, the consequences. And guess how it defines the context in Michael Nagard's template and its description? This section describes the forces at play, hallelujah, including technology, political, social, and project, local. These forces are probably in tension and should be called out as such. Who uses ADRs? Do you do that? No. Decision. This section describes our response to these forces, how they come into balance, right? We don't describe it like that. So what I'm trying to say here is that once we actually start understanding those forces, and I was, in a very cursory way, I was looking at certain design decisions and the forces at play. It's a conversation that you have, and it's not a simple conversation. It's not a 5-minute thing. It's hours and days. The analysis should not be a small proportion of your development effort or your design effort. Problem analysis should be a major part of your design effort, right? And when you're having all those discussions, and when you're modeling these forces, and when you're seeing the conflicts between them, and you're making certain design decisions to bring them into balance, you are recording them, right? And that's one way of recording them. Also, in building evolutionary architecture, there's this concept of fitness functions. These decisions that you are making, these decisions, some of them can be described as or formalized as fitness functions. And they run and they actually hold your design in place. The decisions that you made about your design from the problem analysis perspective, they hold those decisions in place until they change so that you're not veering away from your original thought, right? You can call it bigger design up front, but actually that's what in the evolutionary architecture, they talk about the things that you have to hold in place and the things that need to evolve, right? So your fitness functions do both. They hold certain things in place and they allow other things to evolve in the right direction, right? So you can formalize your these decisions that you're making as part of your fitness functions. So that's all well and good, and I kind of said some things around, well, you need to define the problem at the right level for these forces to emerge. And I kind of showed you some examples, and it's a skill. It's a skill that you need to practice. If you go back tomorrow and you start peering at your backlog and say, like, where is the abstraction? Where do I need to see this thing? You'll need to work a bit at it, because if you haven't done it before, chances are you're not going to succeed the first time. You'll need to keep doing it. What helps is visualizing it, and certain techniques actually help with that. So I showed one visualization, which was essentially a graph structure. It's taking each force, each requirement defined at the right level as a node, and then showing the relationships between them, right? So that's a good way of showing the whole thing. You need to see the whole thing, by the way, right? And it's only when you see the whole thing and you can start creating those clusters, you can then start concentrating on just those clusters. But at any time, you need to be able to zoom in and out, right? Because it's when you see the whole thing is when you start understanding the problem. And it may be that a context change has now taken things out of balance in a very different way, right? And you need to go back to the holistic view. So that's one way of visualizing it. This is Game of Thrones characters and how they interact with each other. The thickness of the arrows is basically the intensity of their interaction, right? So it's a good way of seeing these forces at play. A very old-fashioned context diagram, that's what they were called. Different things at play and how they impact your solution. A use case diagram, right? Maybe you need to adopt it a bit, but that's what it's meant for, is to give you this holistic view on your problem, on your full set of requirements. I thought I had to put that there. I don't know, Simon might still be in the room. So C4 model is also a good way, and it allows you to zoom in and out, although you'll have to think there is a level above what it calls a context diagram, because it's talking about the impact of forces onto the solution, but not the impact of the forces onto each other. So there may need to be another supplementary diagram on top of that. Event storming, right? I like that because it actually allows you to explore the problem without too much kind of bias on the lexical sets, right? So you start looking at the problem almost bottom up, right? And this is a good view because you avoid bias in terms of how they cluster, and you start seeing the clusters in themselves. Again, I'm not saying that they're all perfect in achieving what I am trying to say is to look at the problem in a holistic way, but there are ways and means to do it, and you can adopt them to get you to the point where the interaction between these different requirements or different forces start becoming apparent. You can also use sketch notes if you have artists in your team. right? It's a brilliant way of seeing the thing holistically, but also seeing certain details that matter, right? Because that is the beauty of a good diagram, is that it's showing you the whole, but also showing you the structure of the problem, and that problem, as I said, frames the solution. So in a way, it's also showing you the structure of your solution. Think of a map, right? Even if you look at a map, like these road atlas that we used to have in the old days, I'm showing my age, but it's a map that fits on maybe a A2, and you see the whole of the UK, but you also see the major roads. And if you zoom in, you still see the roads, but you see more, but you see those major roads still. It doesn't matter how much you zoom in, you see that that you saw on top, right? So you see more detail, but you also see it map onto the larger context. That's a beautiful diagram, right? So look at diagrams that can help you see your problem context in its own light, and it illuminating your solution. I know I said lexical sets, but when I start looking at various forces, I kind of think about these different things, right? So if you're trying to kind of work top down into what your problem really is, or what the context really is, you can start looking at these lexical sets. But just be careful that use them to to come up with these things and at the right level, or to go down to the detail, but don't then start creating modules based on them. Utility is functional requirements. Organization, I like to think about the boundaries within your organizations, and of course that matters, right? It's not the solution that has to fit the organization. It's it's not the organization that has to fit the solution. It's the solution that has to fit the organization. Organizations are much more difficult to change. So don't be so arrogant to think that I'm going to design this and everything, the world will just kind of align itself to my solution, right? Economy is a major thing, right? Economy in change, economy in running the thing, and economy in creating the thing, right? And economy in all ways. It's not just about your platform cost. It's about your cost. It's about your time. It's about other people's time. It's about the effort that it takes. All these things are to do with economy. Verification, right? You need to, once you model your problem well, you need to be able to verify it, right? And I don't just mean testing, like static testing. I mean all sorts of testing. I mean even like talking to customers and all sorts of verification, right? Operation, so it's the other side that we need to pay attention to how this solution will be operated. It's about responsiveness, security, economics actually comes into that because it's an overlapping concern. How we detect bad fits, how we recover from them, all these things. So start thinking about those things as well when you think about your solutions. And change, as I mentioned. The stability, to hold the design in place, to make it stable in places it needs to be, to allow it to evolve in the places it needs to evolve, and to make it descriptive so that when someone else comes to change it, it's economical for them to change it. So, I think it's quite obvious why you do this, but I'll iterate. So we are armed with solutions and we are looking for problems, right? We have a lot of solutions and they speak to us, they excite us. The problem is not as exciting, it's more complicated, but that's not that's not a good reason for not looking at the problem. In fact, if you're just looking at solutions and paying these cursory nods to the problem and happy with getting drip-fed stories and not looking at the holistic problem that you have at hand, you will never come to a good solution. You are in a lot of pain. You will be in a lot of pain if you're not already. Right. So we are often too detailed. We kind of look into one thing, even when we are kind of telling ourselves, yeah, you know what, I'm looking at the problem and I'm looking at the solution. We kind of start diving into the detail, and we very rarely come back up. And if we come back up, it's in not a good, meaningful way. It's not in a structured way. We don't look at the whole in a way that actually speaks to us, right? We ask, where's the vision, or where's the roadmap? Yeah, they're good things, but you need a lot more than that. Avoid bias. Divide the problem according to these forces. Don't start using lexical sets. I mean, they can be there to kind of inform certain things, but not to see the different forces that are at play and how they conflict with each other. And this is an important thing to understand. One thing I'm not saying is that you shouldn't listen to guidelines. You shouldn't listen to standard ways of doing things, because once you start analyzing your problem, certain clusters that you see of that problem, you will have seen them before. And it's actually that kind of catalog that you need. It's like, how are these forces balanced, and the solution that balances them, right? And then if you can see in another context the exactly same forces interacting in exactly that way, or even in a generic way, you can start seeing that a solution will fit there. You can start making decisions on, oh, I need to take this guideline now, right? The guideline is that, not too many automated UI tests because they're slower. But yeah, that fits now, but it fits kind of subtly in this way, because this area I do need to do a lot of UI tests, and this area I don't. But yeah, I need to have lots of unit tests for this reason, and so on, right? So you will have guidelines, and they will become apparent, but you need to see them from your problem, the view of your problem. They should not be because it says it in this book, or someone said it here or over there, or it should be because your problem demands it. Your problem context demands it. So, to wrap up, understand the context holistically. I think I'm running out of time. Context is a set of interacting forces, right? So you need to see them as such. Cluster strongly dependent forces together, right? So that will allow you to see where the cohesion is and where you need to create decoupling. Resolve these conflicts with design decisions. And also balance the forces with your design decisions. And document context and the design decisions, and keep repeating. This is the book that actually I took 2 of the examples from, the non-software ones. But the book is about design in general by Christopher Alexander. It's a dry read, but it's very good. Thank you very much.
Thank you, Mash. OK, so we'll now break for lunch. It's been served downstairs. We're back here at 2:15. Thank you.